Welcome back to Educator.com. In this lesson, we're going to take a look at integer exponents. So what does it mean to take a quantity and raise it to a power? There's a lot of other things we'll also be picking up along the way, so let's get a good overview. We'll start off by interpreting what it means to raise something to a power when that power is a nice whole number. We'll see that we can often combine things using the product and the power rule as long as things have the same base. We'll see what it means to raise things to a zero power, and then get into the quotient rule and really getting into understanding what happens when you raise something to a negative power. So watch for all of these things to play a part. All right. So one way that we can look at multiplication is that it's really a packaging up of addition. So here I have the value of x, and you notice that I've added it together 5 times. But rather than trying to string out, x plus x plus x over and over again, then I can write that same thing by just saying 5 multiplied by x. So it's a great way to really take a long addition problem and package it all down into a nice single term. Now exponents, the things that we're really interested in, as long as we're dealing with, say, whole numbers, you can really look at that as packaging up some multiplication. So here I have those x's once again, and I have 5 of them, all being multiplied together. But rather than writing all that, I'm going to use my exponents. Specifically, the bottom here will be our base. Remember, that's what we're multiplying over and over again. And the exponent itself tells us how many times. Let's get some practice with just understanding how exponents work before moving on. So with these, I simply want to write them into their exponential form. So if I have 5 times 5 times 5, well, I can see that it's the 5 being repeatedly multiplied, and I did it 3 times. So I could consider this one like 5 to the 3rd power. If I wanted to take this one a little bit farther, this is equal to 125. Now, you really have to focus on what is being multiplied over and over and over again so you can properly identify your base. In this one, we have -2 times -2 times -2, and we can see that it is being multiplied by itself 4 times. So we want the entire value of -2 multiplied by itself 4 times, so we'll use an exponent of 4. All right. If we had to simplify this one, I'd have -2 times -2 times -2 times -2, and that would be a positive 16. So again, keep an eye on the base so you know what is being multiplied, and the exponent will tell you how many times to do that. In these next two, we just want to evaluate the exponential expression. Let's see if we can identify the base here. So this is a 3 to the 4th power, and there happens to be a negative sign out front. And in my next example, it's almost the same thing, but it's -3 to the 4th power. Watch how I treat both of these a little bit differently. In this first one, the only thing that is considered the base is actually that number 3. So I'll have 3 times 3 times 3 times 3 multiplied by itself 4 different times. And what should I do with that negative sign out front? Well, it's still out front, but since it's not part of the base, it only shows up once. All right, now I can take care of it from here. So 3 times 3 times 3 times 3, a lot of 3's in there, but that will equal 81. And of course, that negative sign is out front along for the right. And the next one, these parentheses are really highlighting that the entire -3 is really what's in the base. So I'll repeat the entire -3. Okay, now when I look at this one, I'm dealing with a -3 multiplied by itself 4 times. So I know that a negative times a negative would be a positive, and another negative times a negative would be a positive. So the answer to this one actually turns out to be a positive 81 instead. So again, use those parentheses if you have to really help you know what's in the base. It's really good for a lot of those negatives.